first of all, everyone, for making time to join the session today. I'm Rakesh, and I'll be presenting AI Toolbox, and we'll be talking about uh, the patterns, the tools, and also some of the guardrails, like when you're building a Gen AI application. And yeah, so about me, this is my socials. And I'm a principal AI consultant. I'm actually working for Agile AI Insights. And we do a lot of AI and data work at Agile Insights. And yeah, I have close to like two decades of experience in working on Microsoft tech stack. And the most exciting journey has been for me in working on AI applications over the last few months or years now. And I'm so excited to share my experience and learnings with you all. And yeah, so let's get started. So if you want to scan that QR code, I'd love to keep in touch with you. So this is actually the things that we'll be covering today. We'll be going through a quick rundown of the evolution of the Gen AI application tools and patterns. And we will also be covering topics around the patterns and tools, language models, and some of the techniques to improve the responses of your AI models. And we will be looking into a lot of demos as well. And the demos would be about using GitHub models. Yes, GitHub also provides models that you can actually use for free. And you can actually use that for your experiments and POCs. And you can also use that for the production. So there is also an option for you to purchase the GitHub models and use that for the production environment. And we will also be looking into AI Foundry agents. This is from Microsoft. And MCP as well. We will have demos on MCP where you can actually connect to MCP from your VSCode. And we will also be looking into some of the guardrails or risk mitigation techniques when you're building your Gen AI applications. All right, so as you already know, large language models are really good at understanding text in the natural language and also generating text in natural language. So they can actually do this because they have been trained with vast amount of data. And with this language model, we started building applications that could be taking care of text generation, summarization, and translation, and also classification. And then we moved on to building applications that would be around virtual assistants, and that can also interact with users in a natural way, in a natural language. And while we are working on these applications, we also found some shortcomings. So things such as hallucination, so where it can not always generate factual output, and lack of real-time knowledge because they have been trained on static data, so they may not give you most recent and accurate information. And context limitations is where like you can work with a model, but there is a limit to how much of data it can process and output. So you can, when you're dealing with large documents, you may have some limitations around how much of data it can. So there are techniques to go mitigate or like go around this, but these are the issues that you would actually face when working with the model. And inability to perform action. So LLM can generate the text, but it cannot automate. It cannot connect to your environment. And there are again techniques such as function calling, which we'll be looking into shortly, which will help to fix that gap. And being biased is LLM model are again trained on a certain data, and that data can be biased, which can be leading to unfair or unethical outputs. So you will implement some guardrails around the responses to make sure that the response that you get is acceptable for your application. And now let's talk about the techniques that we kind of started applying to overcome these limitations and improve the quality of the responses. So first is prompt engineering, as you know. So this is actually the primary flow. So where you pass your text input, and that's your primary content, to the large language model, and it generates the text output. And in order to improve the responses, you would add your system instructions. So system instructions would actually set the context for the conversation and also provides instructions for the model to improve its behavior. So, and also you can provide samples of inputs and outputs to the model so that it aligns its output that it generates to the same samples that you provide. And also you can pass some memory or some samples which would provide the context for the model to generate the responses. And the next option is retrieval augmented generation. So we'll probably not go into the details of it, but this is about providing your data to the model, providing the context of from your data to the model when it's generating the response. So how you do it is you send a text input, and with that input you will go and fetch the data from your data source using that text input, which has the same semantic meaning, and then pass that to your model. So when, in order for you to fetch the data from your data source based on the user prompt, you need to execute something called vector query. So all the data will be represented in the vector format. So your user prompt gets converted into a vector format and you run a vector search and you pick the data which is your supporting data coming from your source, and also include that in the request that you send to the model so that it generates more relevant responses. And again, there is a limit in how much of data that you send to the model, and you need to make sure that you get the best top n records from your data source, and you're within that maximum limit of the payload that you send to the model. So yeah, search is also a key. And yeah, function calling. So some models also support function calling. So the way this works is you define a set of functions that the model can call, and these functions have specific parameters. So it's just like a normal function. The function name and the parameter that it would require to execute. So the model returns a structured output. So the model does not execute your function, but it actually returns a response saying that it needs to run this function, and it also populates the parameters that it would need the function to use. So if the parameters are not available, it keeps prompting the user to provide until it actually gets all the required parameter values. And your host application, like the orchestrator here, would respond to the model and execute that tool call. It will check if the response that you're getting from the language model is actually a tool call. If it is, then it would execute that tool call, and it would then pass the response from the tool along with the original request, so that the model now has the result of the tool and the original prompt, and it will give you the final response. So let's look at the quick example. So this is about getting the weather. So the top pad is the language model, and this is your application. So you're asking what is the weather at Melbourne, and you're also saying that there is a function called getWeather which requires location. And the model determines that I have access to this tool and the question is about the weather. So I would go and request for a tool execution, and I know that the question is about the weather in Melbourne. So that's your parameter value, and your AI application will execute the call, and it will send the response along with the previous message, and then the model finally comes back with a human response which is more clear. Okay, so the models are not just limited to text, they are evolving, and now we have multi-model support, so which means you can input using text, image, video, and audio, and also it can generate text, image, video, and audio. So the models are also evolving, and you can deal with most of these media types. And these are some of the attributes that you would see of a model. So the size parameter is the number of parameters that the model can accept. More number of parameters, the better responses, but it also means more cost and more resource intensive. And context is the maximum number of tokens that the model can handle in order to produce your responses. So when you are actually working on an AI application, so it's not about just getting the model which produces the best responses. It's also about the cost and your use cases. So choosing the model is also a key criteria in the success of your AI application. So many of the platforms allow you to compare the models against various criteria, and then it's easy for you to decide and pick the correct model. And you will also run some evaluations like based on your prompts and see the output, and you would evaluate against various metrics, right? So and then compare the results from each of these models, and that would be your input. All right, so most of the techniques that we have discussed till now is all about context engineering. It's actually the process of managing the information that's passed to the model during the conversation, and this includes keeping track of the conversation history. I mean, so the model doesn't have its memory of its own. So you would also have to actually pass the previous conversations to the model so that it's able to generate, like, I mean, follow-up answers on that. And this is also important when you are actually building an application which is more conversational and which is more complex. So your context would be the key. And I've also summarized what you can pass to the model. So your instructions, the system prompts that we discussed, the input from the user, the examples, and additional data, which is your data. And you can also pass some metadata, so use things such as user ID and all, and tool definition. So schemas is something where, like, you can pass the tool, but when you're expecting the response back from the model, you may want to automate things. You may want to actually take the output from your model and execute or pass that to a different system. So which means you want to get the output in a JSON format, which is the standard when you're dealing with multiple applications. And you can pass a schema to the model and ask the model to generate the output in that JSON format. So you can feed that into your next component in your solution. So when you're automating things. And history, we spoke about history. Passing the previous conversations would also be helpful. All right, so GitHub. Has anybody used GitHub models? Nope. All right, so GitHub also provides models, which is free. So I would want to underline the word free. So all you need is a GitHub model. And the only catch here is it has a rate limit, which means like it has a limit on the number of transactions that you can run over a period of time. But for your experiments and POCs, you can still actually do a lot with just GitHub models. Let me just show you how this works. Right, so I'm on GitHub. So that's your link, marketplace. And you can actually go to the playground. You can have access to pretty much all the models that are available now in the market. And you can select a model on the playground and you can start chatting with it straight away. And you have access to all the parameters that you can send to the model. You can actually update them and then check the responses. And you can also click on this button called use this model, and you can generate a key or a token which you can then use in your own application. And you can use something called code space. So it's like running VSCode on the browser. You don't need to install anything locally. So I'm on the browser and I can run the application, sample application there. And there are a lot of samples. Python, .NET, Node. And yeah, so that's one good way to learn more about working with models. And you have different SDKs also that you can choose. OpenAI SDK or Azure SDK. And as I had mentioned earlier, you can also compare models by clicking on this compare button. You can actually pick one or more models and compare against different criteria. So this is the list of all the models that we see on GitHub. Sorry, does anybody have any questions? Yes. Yeah, so on GitHub, it's all free. So you just have a rate limit, but it depends on the platform from where you are using your model. So on Azure, it works, the pricing works differently. So it's charged based on the number of tokens that you consume. And also there is a PTU model, like where you upfront pay for the tokens. I mean, you go with that approach if you're clear about how your AI application works and you reserve the tokens upfront. So, but on GitHub, it's free.
But two models should not create same billing for same number of tokens, right?
Sorry?
Like two different models should have different billings for usage, right?
Right, yeah. So on Azure, yes, but on GitHub, it's free. But you can actually use the GitHub model, productionize it, and then you'll be charged for it. I'm not exactly sure about the pricing that works for GitHub, but
I mean, I'm asking for the rate limiting, the free tier. Like if I use 3.5
mm-hmm.
model, and if I use GPT 4.1 model, like the number of allowed requests for free should not be the same for both the models.
Yes, that's not the same for both the models, and it also depends on the number of requests that you send in a certain period of time. So that's your rate limit. Yes.
Not about data models, but
Yeah.
you said before for the context engineering and function calling and everything, you all have all that. You gave the example for the weather thing. My question is like, you showed the weather workflow, but you have to go through so much trouble to pass it to the model and then call the model and then call the function and everything. And this applies to any number of workflows. I was trying to
Right.
as well, but why should I go through all this trouble
Right.
of creating an LLM, then writing code,
Yep.
pass the function and all that? And this applies to any number of workflows that we do right now by
Yeah.
function chaining API call, which is it's producing the same result as
Yeah.
this. So why would I use this?
Yeah. So, I mean, this, I would say, it's actually the fundamental principle that we started with to extend the model usage outside your model, right? I mean, if you want to automate something, so you would produce tools and the model will come back and say, okay, so I need to call this tool, and you would orchestrate that. So, you would orchestrate that using a framework. So, which means you don't have to go to the low level details of saying, oh, this is actually the output that's coming from the model, and I need to parse the name of the method, extract the parameters. All this is actually done by you, for you, by a framework. And if you're on .NET, you can use something called Semantic Kernel, where it internally orchestrates all this, right? So you don't need to actually do all that. But with the tooling, even that is evolving. So what we have now is, like, if you are using AI Foundry, that comes with out of the box tools. Like, unless you have anything specific and you want to write custom. So AI Foundry, which I will be talking about shortly, also comes with out of the box tools. Tools as such, you can categorize them in two ways, right? So one is knowledge, which means like data sources, right? It could be your SharePoint or it could be anything. And action tools, where you go and execute actions, call an API or something. And now what we also have something called MCP, which also I'll be showing you shortly. So MCP is like a collection of tools. So you don't need to write, you just need to say that I'm going to be using this MCP tool which knows how to talk to the database, and I'm not writing each tools like how do I query. I'm just connecting or making that MCP server available to my LLM, and all the calls will be orchestrated by the LLM. I'm not like orchestrating them in my code. So if that makes sense. So this is like a very foundation level. So where you are giving your tools and what's going on behind the scenes.
Yeah, but like even in big enterprise workflows and everything, um, sometimes most of the time there's a requirement to execute a specific set of business rules or like a specific set of functions.
Right. So where you are clear about the rules, there is no point in introducing AI into it. So it's not going to add value there. So where you need something to make that decision, where you have like dynamic flows, right? So you cannot have if-else statements or very concrete set of rules defined. There you would use AI so that it's able to like reason, saying, okay, now based on this information that I have, I want to call this, right? So only in those instances you would make use of AI, but not to just repeat whatever we are doing now by adding AI. So that's not going to add value. All right. So I just want to show you this one before we go into the lab. So this is actually one of the labs that I prepared for the previous workshop. So it was run in 3 streams. So we start with the basics. Where we explore like how to talk to the models, the agents using notebooks. So .NET, you can also run .NET on notebooks, just like Python notebooks. So that's your first lab. Second lab is a little more advanced, and we use Azure AI Foundry. And third would be the lab where we will be building an end-to-end application. So if you are interested, you can actually scan this QR code, which takes you to that lab, and you don't need to install anything on your system. You will be using CodeSpace, which comes with all the tools pre-installed, and you can just use your browser to run the lab. So let's have a quick demo of the function calling. So for this, I am using the same lab, and I have created a code space for it. And yeah, so you can hopefully see that. And there are some notebooks. So this is from the first lab, and I expand semantic kernel and function calling. So has anybody used notebook before? Python? Okay, that's great. So it's so easy. Uh, so you have this play button. You can actually add text and also code, and you can click on the play button. And for when you're learning or experimenting with something, it's very easy. So let's start with the first one, right? So what you do is like just open this notebook and install some NuGet packages that would be required. So in this example, we are using the framework called Microsoft Semantic Kernel, which will be an abstract level for working with the models. So I'm using .NET, reading the environment variables, and this example is using GitHub. So if you go to that lab, it will talk about the steps for generating a token, and this is the token that I'm actually using in my environment file. And that will be read when I'm running this block of code. So it will read the environment file and fetch the GitHub token, and this is where we call the function. So in semantic kernel, it actually gives you two options. So one is called semantic function and a native function. Semantic function is like purely text. So this is your prompt, and it has a placeholder for a variable. Like this is to summarize a text, and you pass the number of words as an input, and so this is the content you want to summarize, and then you call the function. So this is the place like where you call the function, and it summarizes it for you. And you can also call native functions, so which is like your C# code. And in this example, I'm having a weather plugin. So this is hard coded, and it actually picks up something in random out of these weather options. It's not calling an API externally. So, and also it has another function like in the same plugin for checking. So the whole theme for this lab is a bike store. So that's where like you have this function that says check bike availability. And then if I run this question, which says, is the Contoso model speedster bike available in the store? So it would be able to use that function and give me the response. Oh yeah, sure. Sorry. Oh yeah, so finally, yes, the Contoso Speedster bike is available in the store, and it's saying yes because it was there in my dictionary, which is the hard-coded list. And similarly, I can run this other query which says what is the weather like for the bike ride today, and it would be able to use my weather plugin and then generate this response. I'm not going to run this again because already you can see the answer and spend another 30 seconds or more. All right, any questions on this? Any questions on the lab or something?
C# classes?
Yes, I mean, it's a part of the semantic kernel library.
No, no, your code.
So this is notebook, so you can actually execute the code part by part. So it remembers the previous context, and yeah, so you don't need to have it in the same class also. So as you can see, I don't have a class defined here. Move to the next topic. So agents. So with the techniques that we have discussed so far, we can create really powerful assistants, and they can be used to probably build a customer support assistant which can automate responses to common customer queries, and also content creation. You can use this uh, models to probably generate articles or blogs or social media posts. And data analysis, we saw in a small example where you can actually ask a model to summarize the data. And but agents are different. So, but what sets agents apart is their ability to perform tasks autonomously, and it has good knowledge of the domain or the environment it operates in, and it can use the tools to retrieve the information or perform the actions. So, for example, an agent has three core components: a model, like which can be used for reasoning. So it can actually understand the natural language and generate an output in a natural language, and the system instructions that we saw, and the tools. So it's like you are when you're developing an application. So we have worked on microservices, right? So where you're breaking down the functionality into a smaller set of tasks, and it's a similar concept. For example, you can have an AI agent that specializes in a specific domain like a customer support, and it can use tools to retrieve information from its internal knowledge base and perform actions like updating tickets or sending out emails. So you can also use multiple agents and build a multi-agent application. So they can work together to achieve a common goal, and this is particularly useful when you have a complex task, right? So you're not like dealing with one agent which overloads the agent. So you're dealing with multiple agents to solve that complex task, which can collaborate together and complete the task. And as an example, you can think about a travel planning application, right? So where one agent can specialize in booking the flights, and another agent can probably uh, look at booking the hotels in the area that you select, and another agent can maybe suggest attractions like on the place that you want to visit. So all this can be collaborating together to plan your itinerary. So that's one sample use case. And the advantage that you get with multi-agent applications is distributed problem solving. So you have different agents specializing in different areas, and they all collaborate together to achieve your common goal. And scalability. So if it's a centralized system like you saw, so as we feed more and more tools, so there is actually a limit. It actually creates a bottleneck. So if you have multiple agents with its own set of tools, you can actually scale your applications better. And flexibility, if an agent is not performing well, you can swap it with a different agent, but your solution is still intact. And speed, so you can also run these agents in parallel if the speed is also a concern. And when you have multiple agents working together, sometimes you may still want to have control on the sequence of execution. So these are some of the patterns that you can actually use for orchestrating the multi-agent applications: sequential, concurrent, and handoff. Sequential is like you execute the steps one after the other. The output of the previous step will be the input for your next agent. So it could be used in a use case like where you have a document processing pipeline, right? Agent A is good at extracting the text from PDF or any other sources, and agent B can summarize it, and agent C can maybe translate it into a different language. And yeah, so similarly, you have the concurrent, so where agents can also be orchestrated to run in parallel. And handoff is something that an agent decides to hand off to another agent if it's not able to execute that task. So there are different patterns. And yeah, so the next samples or demos will be around Azure AI Foundry. Has anybody used Azure AI Foundry? That's good. Right, so it's actually a platform from Microsoft which streamlines the creation, deployment, and management of the AI applications, right? And also the agents. So it makes it easy to build, test, and also manage all the AI solutions, and it also provides access to the models, like similar to what we saw in GitHub. It provides access to the models and some of the out-of-the-box tools and resources. So it also gives you governance and compliance features, right? So you can actually say, so for my project, I have so-and-so models, and I will be giving access to these models and these services to a certain team. So you can have all that security and the governance features. And you also have something called Azure AI Agent Service, so which we'll be looking into shortly. So this is Azure AI Foundry Agent Service, and this is where like you can use or create agents in AI Foundry, and it can manage the threads, the messages, the tools for you, and you can also it can also execute the tool calls on its own, which means like you don't have to like execute through your code. You can like have AI Foundry execute the tool call on its own and feed the response back to the model. So let's look at the quick demo of AI Foundry agents. All right, so this is actually coming from the lab again. So when you run the deployment, which is a part of the lab, it creates all these resources for you. So this is where you go to the Azure AI Foundry portal, and you have access to all the models similar to what we saw in GitHub. And you can choose the model and again like run that on a playground. And these are some of the parameters that you can actually configure. And it's not just a chat playground, but you can also have other playgrounds on AI Foundry, so speech playground, video playground. Deployed for this lab. So one is GPT-4 and the other is embedding model for creating vectors. And in Foundry portal, you also have a lot of templates that you can just deploy and run. And these are some of the examples from Microsoft. So agents, so this is actually how you create an agent. You can actually create an agent in the portal itself. So you specify a name and you specify the model that you want to use and the system instructions. And you provide a brief description. So tools come in two categories. One is knowledge tool and the other is action tools. Knowledge tools is your data source. So it can be a file. So in this example, we are just uploading a file, a PDF file, which is about the bikes, the policies, the return policies of that company. And when I upload, so internally what's happening is it's going to vectorize the data and make it ready for the agent to interact with. So you can actually talk to your agent now in a natural language. So if I ask questions about the policy, what is the return policy of my Qantas or bikes, it's able to actually use the data it has and generate a response. So you can also see the execution. So you can see that there was a step where it had to call the tool called file search, which was the out of the box tool which we configured for this agent, and get that response and provide and generate a final response. And it can also capture details about the tokens that was consumed in generating this response. And again, like similar to GitHub, or you can download the source code in different SDKs, and you can run that from your IDE. So these are some of the action tools. So you can actually call an API as well by providing a Swagger, and you can add more, connect one or more agents also to this agent, which means like you can build a multi-agent solution from the AI Foundry. All right, and there are a couple of other demos or labs that are available. So which actually walks you through how you uh, do a similar thing using your C# code. So I would actually just share a reference to that lab later. But if you are actually consuming if you want to consume this uh, AI Foundry from your application. So what you would do is, like in this case, it's a full stack application. So you have your React app as your front end, and you have your back end. Like in this case, it's a .NET application, and it uses semantic kernel. So when you interact with your React application by sending the user prompts, it would call the backend, and the backend would actually use the AI Foundry, that's the agent that's deployed in AI Foundry, and create a thread, get the response, and feed that back to your React app. So in this quick example that I have, it's for a tech support agent, and what it does is actually it's able to answer queries about resetting passwords and checking the system statuses and more. And I'm using something called uh, not external tools, but the local tools which you can build, and just mocking the responses, not calling any API in this case. So let's look at the quick demo. So again, this is covered in the final lab. Sorry, not this one. Yeah, so there are actually some steps for guiding you how to create the Azure resources, and you can get a free credit from Azure if you're signing up for the first time, and that's good enough for running all these samples. So you use the same resources that's deployed here, and you then navigate to your website, which is this app, a React application. And this is the code. It has a controller. This is the .NET API, which actually delegates the call to your AI Foundry and gets the response and returns that back to your React application. And this is the front end. So if I start typing in questions right here, and it goes and uh, submits a request to the backend API and generates a response. So in this case, I'm saying, could you please provide me with John Doe's email address so that I can send a welcome email? And no, the question that I sent was send a welcome email to John Doe. So it's actually prompting me saying, can you please provide me an email address? And then because it has now access to his email address, it's able to go and execute the tool call and generate the final response. So we have the source code in the GitHub repo that comes with the lab. If you want to like go into the details of how that works, please yeah, look into that GitHub repo. And let's actually talk about something called MCP. Right. So in the previous approach, like where we were using tools, we were feeding in individual tools, right? So each model has its own way of saying, this is the tool call that I want to execute, and each tool has its own APIs and things. So for each model, you will end up creating a custom implementation. So which means like for m number of models and n number of tools, you will have m into n number of implementations of the integrations. But with MCP, it tries to actually standardize the communication between your models and the tools. So you would end up writing just m plus n number of integrations, and your model talks to your MCP interface, and the tool implements the MCP interface. So it's m plus n integrations. And what's an MCP server? It's an open source. It's a standardized interface that allows language models to interact seamlessly with the external APIs, tools, and data sources. So in case of MCP, the models and tools have to implement the MCP interface just once, and which means you can use the same implementation for all models and tools that support the MCP. You don't need to have any custom implementations, and you can actually go to this website here, which has the, actually it's a GitHub repo which has a list of all the available MCP servers that you can try, and the list keeps growing. And you can also use MCP servers with your VS Code. And this is actually the list. We'll be looking into that shortly, and this is going to be one of our demos. All right, so the MCP server can provide three things: resources, which is actually the data in the read-only format, and it can provide tools like the functions that you can execute from your model, and also it can provide predefined prompts or prompt templates that you can use. You can actually define a set of prompts, so you don't need to repeat that in your AI application, and your MCP, from your MCP server, you can download that and execute it in your AI application. And with respect to the components that is a part of your MCP, so you have an MCP host. This is your application, AI application, or a host that interacts with the tools. And MCP client is the component that maintains a connection with the MCP server. And MCP server is actually the server that implements the tools. It implements the tools that can actually fetch you data, execute actions. And the tools can be probably at the simplest example, it can be a tool that reads your file system, gets the data from your file system, or maybe a data, or maybe execute an API call. And in terms of the execution flow of your MCP interaction, so it's similar to what we saw earlier, like the tool call. So where you provide the context of the MCP to your model, and the model will now be able to go back and tell your orchestrator or the AI application that it needs this call to be executed. And then it would execute the call, the MCP server returns back the response, and that is fed into the model, and it generates the final response. And as you can see, a tool can also be an MCP server, so which means it can grow exponentially. So in here you can see that this tool one is an MCP server, and which has access to more number of tools, so it can grow exponentially. So whereas in the previous case you were supplying all the tools to your model, and because we have a limit to the number of tools that you can pass to the model, it cannot scale well. But in this case, the MCP server, you can exponentially grow the number of tools that you have. Yes.
Tool 1 has an MCP client to connect to MCP server B, right?
Sorry?
Tool 1 at MCP server A has a MCP client to connect to MCP server B, right?
MCP client would be common. So this is actually a part of your host application which maintains the connection to your MCP servers. It could be MCP server A, B, C, anything. So that's one instance of your MCP client, which is the bridge between your host and your server.
How tool 1 is calling MCP server B?
Sorry?
How tool 1 in MCP server A is calling MCP server B?
So that's probably internal, and yeah, so I'm not quite sure. So it probably can have its own MCP client if that's the implementation it has, but usually for an MCP host, you have one MCP client. All right, so let's actually look at a quick demo of the MCP server. So all right, so this is the list of all the 10 minutes. Okay, sure. So this is actually the list of all the MCP servers that's available for the VS Code, and you can actually choose to install it. So I'm installing the MCP server for Microsoft Docs, which means you can use GitHub Copilot in your VS Code and give access to the Microsoft search documentation. Microsoft documentation, sorry. You don't need to go open a browser and search for things, but you can actually have that within your Copilot. And this is all the list of MCP servers that I have. And Microsoft search has now been enabled. And now I can type in a question and it goes and, okay, maybe I'll just zoom in if that helps. So I've asked a question, so it's able to see that it has access to this MCP tool called Microsoft Doc Search, and it asks for my consent whether it can go and execute that MCP tool. And once I provide my consent, it would go and fetch the data, interact with the tool, and provide a response for me. So in this case, I'm asking about the CLI command. So it's giving me the full details here. So you have to make sure that you're on agent mode and you have the MCP tools installed. All right, so that's for using the existing tools in VS Code. So you can also build your own tool. So it's very simple. I'm using a .NET framework, and I have two MCP tools, which is again like about getting bikes from the Contoso bike store. And I have two functions: get available bikes, and I think there are more functions: get bike by bike ID, which which goes and calls an external API to fetch the data. And let's see how I can use this tool which we have built in Visual Studio as an MCP tool in VS Code. So I'm registering that MCP tool and I'm running this locally. Oh, sorry. Yeah, so this is how you configure the location to your MCP tool. So I'm pointing to that project which has the MCP server project, and this is the JSON file that you would use to specify all the configuration, and then I start the server. And then now if I ask about the bikes, it's able to identify that it has access to this new MCP function that I provided, which is about getting the bikes, and it would call that. Let me zoom in. So I'm asking a question as what bikes do I have in the Contoso bike store? So it's able to find that there is a function called get available bikes. It's calling that function and it's pulled the data. So the data is returned to this in JSON format, and Copilot is able to format that in this natural language text. Okay. So this is actually the data that was used. This is the static data, I mean, which is in the JSON, which is actually saved as a JSON file, and that's exposed through an API. And the MCP server calls this API to fetch the data based on your question. And you can see that I can also be more specific. I can say, oh, what about this bike? Can you get more details about this bike? So it goes and executes another API, which other tool, which is for fetching the bike information based on an ID. So it has that intelligence to understand your prompt and then decide which function to call. So that's where the model power can be used. Okay. So let's actually go into some of the advantages quickly. So it's a standard protocol, which means like you're building and maintaining, you build and maintain custom integrations using a consistent and scalable approach. And as vendors evolve, like it could be vendors who work with uh, maybe different databases, APIs. So they can evolve, and the MCP server would also be maintained by them. So you don't need to actually worry about breaking code changes. And it's plug and play integrations. You can actually get access to a lot of MCP servers that are already out there in the market, and reusable. The models and the tools only need to implement the MCP interface once, right? And you can reuse the existing stuff. And security and governance, because you are centralizing the access to the MCP, so your auditing, security controls and all are centrally managed. Okay, I'll just quickly show you last thing. So when you are working with generative AI applications, you would also have to actually tackle some of these risks around your AI application. So, I have tried to summarize all the risks in this slide, and this probably not go through the entire list, but as you can see, as we have discussed, with respect to working with the model, right? So we have some issues around the model being indeterministic, hallucinates, and it's also biased. So you would have to actually use prompt engineering and other techniques to mitigate those things. And also, as a bad actor, you can maybe have hackers who can actually send malicious system prompts to try to break your system prompt and get access to the data within your application. So you would have to actually tackle that. And with respect to output also, the model can generate output which is probably sometimes not relevant, harmful. So you would have some guardrails around your responses between your model and your application so that you can mitigate those issues. And when you are creating your tools, you would also have to make sure that you don't accidentally expose information to the model that you're not supposed to. And this includes things such as PII and other business data that should be handled with care. All right, so, and yeah, so in Azure, you would also find something called content safety service, which you can use to shield some of these mitigations. So you can actually use Azure AI Content Safety Service for input as well as the output. So which means like when the user sends in the prompt, you can have various categories of control like violence, hate, and sexual content and self-harm. So you can have different levels of moderation and also the same controls on your output from your model. So you can use that. And that's it. So,
Oh, cool.
thanks
Thank you,
again,
Rakesh.
everyone. Any